Hi friends, now let us start the next chapter in our version policy, that is light chapter. We have successfully completed two chapters, namely first one, that is current electricity. Two videos are done, part 1, part 2, synopsis and numericals around 19 to 20. Second chapter, magnetic effects of current, we have completed. Of course, it's a boring chapter, completely theory. Hardly we got 10 questions in that one, because successfully theoretical questions. We have completed synopsis. Now I am starting the third chapter for the polisher, that is light chapter. Light. So in this also we will be getting another 10 questions. In light we have the concept called light, reflection and refraction. So these are the things we will be studying. You can take it as part 1 video it is, because this takes around 2 parts, namely it may take 2 parts. We will try our best. First of all, let us complete the third chapter concept, then we will go to numericals. Okay? So first of all, we have to know, according to our new syllabus, what is the definition of light and what all we will be studying in this chapter regarding the examination. First of all, the definition of light. So we all know light is a physical quantity. Light is a physical quantity when it falls on the retina, because just like a camera, our eyes also acts like a camera. Okay? When it falls on the retina of the eye, it causes sensation of sight through the optical nerve or optic nerve inside it. This optic nerve is very much responsible for observing the things or the beauty of the nature. So if you want to see anything in nature, first of all, the optic nerve present inside the eye should work properly. If it is not working, you cannot see the beauty of the nature, or you cannot see the object even though you have your eyes. So light is a physical quantity when it falls on the retina, causes sensation of sight through the optic nerve present in. That is the exact definition of light. Now, in your syllabus, we are having what is reflection of light. Okay? So first of all, we have to know what is meant by reflection, and thereby we will be knowing what is the things present in it. First one is reflection of light. Reflection. Okay? So suppose this is the reflecting surface, say PQ, like any wall, and let this will be normal. Normal means which a line drawn perpendicular to the reflecting surface. And we should know one more thing, what is meant by light ray. Light ray. See, this is called when a single, okay, when you take it a single light, this is called light ray, you can see. Suppose when a group of light rays are coming outside, this is called a beam. Beam of light. So a light ray is indicated with an arrow mark, single arrow mark. Suppose a number of arrow marks are coming, it is called a beam of light. Okay? So when this is, always you have to show with the incident angle is normal, not with the surface, please. Okay? So this is the incident light. So when the light ray, after hitting the surface, making some angle with the normal, if it comes back again, that is called as reflecting or reflection of light. That means after hitting the reflecting surface like any wall, okay, if the light again comes back to the same medium, it may be denser medium or rarer medium. Rarer means air. Denser means other than air, like a glass plate, water, etc. Okay? So in any medium, if it comes back in the same medium, then it is called as reflection of light. That is the definition. Now we should know what are the laws of reflection. See, laws of reflection of light is always right. Always right it is. Either laws of reflection or refraction. So we have only two laws mainly. One is the incident angle is equal to the reflected angle, please. This is the first law of reflection. It is always right. Incident angle is always equal to reflected angle. Suppose it is incidenting with 30 degrees. Reflected angle is 30 degrees. 45, 45. 60, 60. That is the first law of reflection. Okay? Second one. At the point of incidence. At the point of incidence. At the point of incidence, the incident angle, normal, reflected angle all lies in the same plane. Very, very important one. Are you following? at the point of incidence, incident angle, normal and reflected angle all lie in the same plane. So when it is coming to the point here, this is the normal. When the light is incidenting at this point of incidence, incident angle, normal, reflected angle all lie in the same plane. That is the second law. And these laws are very, very important in the examination point of view. Regularly they are asking questions from these questions, this chapter. Okay. So these are the laws. After completing successfully the chapter, then we will do the numericals here. So these are the laws. Now let us go to spherical mirrors. Actually, in the spherical mirrors, plane mirror is also there, but for your 10th standard, plane mirror is not there. When you go to higher class, 11th or 12th, there you will be dealing properly with the plane mirrors. Okay, so that is why I am not dealing the plane mirror. Only I will discuss about the convex and concave mirrors. So let us put the second one, spherical mirrors. Spherical mirrors. See, we all know any glass plate which is transparent. Transparent means what? Light can enter through it. Okay. So what we have to do is, any solid transparent material, okay, when it is cut and silvered, then those are called as spherical mirrors, like plane mirror, convex and concave. As I said, plane mirror is not there for your syllabus in higher class 11th and 12th. In your 10th standard you are having only concave and convex mirror. Concave mirror, and second one is convex mirror. These will be dealing properly. Okay. Now let us see the diagrams for this one and details about this. Now when you can call a mirror as a concave? See here, concave. Suppose if the mirror transparent material is cut like this in this fashion, and the outside part is concave. Cave means entering into the cave. So if the outside part is silvered, outside, you can see here, the outside part is silvered, okay, and you can see this is the imaginary line passing through the center. That is the imaginary line passing through the center. This is also called as principal axis, PA. Okay, and the center part is called as pole of the mirror. In mirrors it is called as pole, in lenses it is called as optic center, C. So these are the terms you have to understand very well, because unless and until you know the concept, you cannot do the numericals in the light chapter part 1. Okay, so if outside is silvered, you can say this is the material. I mean, this is the surface where the light is incident. Okay, now this is about what? Concave. In the same way, for example, if inside part, you can see here inside part is silvered and the convex side is incident on the light, you can see. And again the same way, this is the pole and this is the imaginary line passing the center. Again this is called as principal axis. So here the inside part is silvered and the convex part, you can see, that is along the incident light. So this is the difference, major difference between concave and convex. Because anyhow in the syllabus it is not there. For this is a plane mirror means it will be straight. You can silver either this side, this is the incident light, or if you silver this side, this is the incident light. And this is the optic center for the plane mirror. As it is not there for your syllabus, we won't discuss about the plane. This is a plane mirror, straight. One on the side is silvered. And there is no curvature here. R is infinity, of course. The radius of curvature is straight. Okay. So this is the basic structure of the concave and convex mirrors. Now what we will do is we will study detailedly regarding the mirrors. That means how the image is formed. Okay. We will study one by one. First of all, we will deal about concave and then convex. Now this is the concave mirror. This is the concave mirror. This is the concave mirror. You can see the outside part is silvered and inside the light is incidenting. And one more thing before going into details of the mirrors, the conventional signs are also important. Let me tell those also, then only I'll enter into this one. Conventions, that is sign conventions. Because in numericals these are very, very, very important. Either it may be convex or concave or lenses. These are very, very important. First and foremost convention sign, that is, see, always the distances are measured from the pole. Always the distances are measured from the pole only. Pole means the center of the mirror. In lenses, optic center. Okay? So always the distances are measured from the pole, like this or like that. That is the first point. Second one, incident light direction. Incident light direction. Incident light direction is taken as positive. Always the incident light of direction is taken as positive. If you are measuring the distance along the incident light, it is taken as positive. Against it is taken as negative. Suppose you are measuring the distance along the incident light, then it is taken as positive. If you are measuring against, then it is taken as negative. Are you following the point here? If you are measuring the distances, always the distances are measured from pole only. But suppose if you are measuring along the direction, okay, that means like this, along the direction means it is positive. Against means, against the light incident means it is negative. The conventional signs, very, very important, please. Third point, above the principal axis, it may be height of the object or anything, it is taken as positive. And below, that means this one, below the principal axis, it may be height of the object or image, whatever thing, it is taken as negative. These are very, very important. Please note down, all of you, please. In the numericals, you will be facing a lot of problems if you don't know these conventional signs. Above the principal axis is taken as positive, below it is taken as negative. Are you writing now? Right. So these are very, very, very important regarding the conventional sign of any mirror or lenses. Okay? In lenses, you will be using as optic center. In mirrors, you will be using as pole of the mirror. Okay? Yes. Now, after knowing about these things, already I told you, all the distances are measured from the pole. And one more is left over regarding focal length. Regarding focal length, which is indicated as small f. Okay? Now, focal length means here, what is meant by focal length here? We all know this is the concave mirror. So, concave mirror, you can see the center point will be this side. This is the center. This is also called as center of curvature, because the curvature is in this fashion. Whereas if you see convex mirror, you can see the silver part is inside and the center part will be this side. Center part will be this side. Okay? So regarding convex, the radius of curvature will be along the incident light. Whereas in the case of concave, the radius of curvature is against the incident light. So in this case, what happens is, focal length is, you can see almost in lower classes, focal length will be taken as the center, that is focus. But in higher class, it may not be at the exactly center. Slight eccentricity may be in higher classes. So in general, you will be taking the center of curvature. The center of curvature is taken as focus or focal length. So that is why R is always taken as 2f in lower class. R, capital R, radius of curvature is taken as 2 times focal length in general. Okay? So focal length means what? Distance from the pole of the mirror. So because it is measuring against the incident light, here the focal length is negative, concave. In the case of concave, it is negative. Whereas in the case of convex, it is along the incident light, you can see. So here focal length is positive. Please make a note. So here focal length is positive because along the direction of light. It is against the direction of light. It is negative here. In the same fashion, radius is also negative for concave because all distances are measured from the pole against the incident light. So R is negative. Whereas in this case, or is positive in convex mirror. So these things, if you put in your mind, you can solve any problem later on. Okay. Now let us go further in this subject. Clear? All of you noted down regarding the rules and regulations of concave and convex mirrors? Right. Right. Now let us see some images and formations and rules and regulations regarding first concave and then we'll go to convex. First of all, if you take the concave mirror here, already given the center of curvature radius, of course it is negative, focal length is also negative, distance from the pole of the mirror, and this is the focus. Focus means when the light rays meet at a point, that is called as focus. First of all, you have to know another important point. When parallel rays, light rays meet the surface, either it may be concave or convex. For example, see, this is the parallel light rays. Any parallel light, always it should go through the focus. Very, very important. Any parallel light rays, it should go to focus. See, even it may be concave or convex. You can see this is a convex. This is the principal axis and this is the pole. Okay. So in this case, already I told you, this is the center, this side, and this is the, of course, this is the center radius of curve. This is the focus and this is focal length. Okay. So here, suppose this is the parallel light rays coming from infinity. Okay. And you all know one more thing. See, this regarding the surface, which is spherical surface, normal is always passing through the center, please. Normal is always through the center. This is the normal. Here also you can see this is the normal. Always pass through the center or diameter. This is the normal. So you can see this is the incident light making with normal some angle theta. So here you can see this is the normal. Parallel light rays meeting the normal. Okay, theta. So after hitting angle theta, again it is going here again. Incident angle is equal to reflected angle. So here also you can see incident angle. Because it is a convex, it is diverging. Incident angle is equal to reflected angle, theta is equal to theta. Because this is diverging rays, what happens? It won't meet, it will go to the other side, somewhere over here. So that is why in the case of convex you will get a virtual image, not real image. Whereas in the case of concave you will get real images and only in one case you will get a virtual image. Virtual means behind the mirror, back side. Okay, not real, virtual. So the thing is, parallel light rays meeting the surface goes through focus. Light rays going through focus goes parallel. These two things you have to put in your mind. Always parallel light coming from infinity should go through focus. Light going through focus will go again parallel. These two things you have to make in mind. And also for this, whatever you have taken the spheres, okay, always the normal will be from the diameter or from the center only the normal will be. So if this is the incident angle with the normal and this is the reflected angle, incident and reflected, both angles are same. Clear? So these things you have to put in your mind. I am drawing parallelly for concave and convex. You can see here it is diverging. So diverging rays never meet each other. When you extend the lines, it will be meeting behind the mirror. That is why here real image is formed. Virtual image is formed in the case of convex, and in the case of concave, real images are formed. Clear? And one more thing, to form any image, 2 minimum light rays are required. Maximum you can take any number. But with 1 light ray you cannot form any image. To form any image, minimum 2 light rays are required. Either in lenses or in mirrors. Minimum 2 light rays. Minimum 2 light rays are required to form any image. To form any image. Maximum you can take any number of light rays. Okay? This point is also, for example, this is 1 light ray. Another one I will take through normal, through the center. Because whenever any light ray is going through normal, it goes undeviated. Again it comes back. there is no reflection whenever the light rays is going through the normal. Because I told you, when light is coming to the incident of normal means zero incidence. So reflection is also zero. That is also you have to put. When the incident angle is zero, the reflected angle is also zero. When it is going through normal, no reflection. Go straight. Okay, again it comes back. Zero reflection. These points also you have to make in your mind while doing numericals, please. Okay, clear? So parallelly I am telling you about concave and convex to save the time regarding the theory part. So you can see the light rays parallel coming from infinity, meeting the concave surface. After meeting, it is going through focus. Okay? Now I will discuss about 2 or 3 points regarding the images formed by the concave and later on with the convex. Okay? Now for example, take this one, first one. So the rays from infinity are coming. You can see the infinity. Rays from infinity. When rays from infinity are coming, you can see this is the center, this is the focus. That means somewhere the object is at infinity. Somewhere the object is at infinity. Infinity means always the light rays are parallel. So it is going through focus. Clear? So what I will do here, I will take some extended object. I will take some extended object. I will take, suppose this is the center. So object is at infinity. For example, say object like this. A, B. This is the height of the object HO. Here HO is the height of the object, please. Height of the object. Now you can see the light rays is coming from the infinity. For example, this is height. One light ray is coming and hitting the surface. It goes to the focus. Second one, what you will do? Same from here, I will take through. See here. Focus. Second light ray. Only 2 light rays are required to form an image. Second one is I am taking through focus. So through focus means what should happen? It should go parallel. So these two are meeting at somewhere over here. And you can see image is very small and inverted. A dash and B dash. So both are meeting at somewhere over a point here. So when the image is at infinity, when the object is at infinity coming and meeting, you can see it is going through the focus. See, I just now told you parallel light rays should go through the focus. When it is going through focus, again it should go through parallel. These things you have to put in your mind first of all. First case. Clear? Shall we go to next case? Next case, what I will do, I will draw here beneath. Next one I will draw here. Okay. If you want, I will give the concave also parallelly. Concave also. Convex also. See the convex mirror. See the pole of the mirror. And the center is over here. And this is focus. For example, if you take convex mirror, what happens? And you know this is the normal. Always passing to the center, normal. Now suppose the light ray is coming from infinity. Light ray coming to infinity, from infinity. When it is hitting the normal at angle theta, what happens? Diverge. Incident angle is equal to refracted angle. These two light rays never meet each other. So it will meet somewhere over here. So again virtual image is forming here. You can see virtual image. So like that you can take any number of parallel lights, diverges, parallel, diverges. All these will meet at here this point at focus. So here virtual image is formed in the case of convex mirror. Clear? Right. So these things are very much important for the numericals when you solve. Okay. Now another case I'll discuss, very important regarding concave. For example, see, this is concave. outside, pole of the mirror, and this is the center. This focus, focal length in other words. Now suppose object is placed between infinity and center, for example, so somewhere over here, AB, between infinity and center. Object is between infinity and center. So one light ray I'll take like this, and you all know this one is the normal. Okay, one light ray meeting the surface, you have to go through focus. Next one I'll take through focus. Next one through focus. Through focus means what happens? It go parallel. It go parallel. So you can see this light and this light both are meeting over here. And image you can see A is coming to A dash, B is coming to B dash. So image is between center and focus, and slightly diminished, inverted, real image. Okay, inverted, size is decreased, inverted, real image. See, in concave mirror, maximum 90% you will get real inverted images. Real inverted images, please. Okay. So this is the figure, and you can draw the next case also here in the beneath. Second case. Now I will take the object at the center. For same concave. Now I will take the object at center, please. See, this is the pole of the mirror. Okay, this is center point, center of curvature, this is focus. Now what I will do, I will take the object at center, extend object AB. This is the height of the object. So this is the light, one light ray. Okay, going through focus. Second one, through focus, will go parallel. Will go parallel. Okay. So I have taken exactly the center. One is I am taking like this. Okay. Going through focus. Another. Suppose if I take through pole. Pole means center. It will reflect. So then I think both will be meeting at one point. So here one point you have to take. That is, try to adjust the image here. Suppose if I take through pole, pole means center. Okay, so it goes reflection. Theta, theta. Somewhere over here. That means exactly when you take the object at center, the image will be at the center, inverted, real, same size. Real, inverted, same size, exact size. Inverted, A dash, B dash. So like that you can form different figures here. You can see. One more I will draw here. Concave. These are different cases we are studying. Now you can take it between center and focus. This is center. This is focus. Now we can take between center and focus object. AB. One light ray. Parallel light going through focus. Another one. Suppose if I take it focus here. Focus means it has to go parallel. You can see the image is shifting now. A dash, B dash. So here little magnification. Again real inverted but magnified image. And image is shifting, you can see. When it's between center and focus. Now you can try with focus. Image at focus. Object at focus. So like that you can draw different figures regarding concave. Maximum in concave you will get real and inverted images. Real, inverted. Okay. Now you can try for next one. You can try for next figure, that is, you can see pole, center, focus. Now we can take the object at focus itself. Now object is at focus only. Okay. Now one light ray if you take like this, Okay. So where it goes now? Another one I'll take pole. Angle of incidence theta. So next one reflects. Okay. So you can see here the light rays are what? Parallel light rays are coming in. Okay. At the focus means what happens? When light ray is going parallel, it has go to the focus one. Another one I have taken to pole. Angle of incident is equal to angle reflected angle. It reflects like this. So light ray is infinity here. You can see infinity. So if you extend, I think somewhere over here it may meet. Okay. You can draw for another also again. Pole of the mirror, center, focus. Now you can take the object in focus and fold. Now you can take the object between focus and pole. One is going like this. Another one meeting. Another one through pole. Incident angle, reflect angle. So in this case you observe this is divergent. This is here it is parallel light rays. They never meet each other. Okay? Parallel light rays. Diverging, what happens? You can, these won't meet, but when you extend this one, somewhere they will be meeting here. A dash, B dash. In this only one case of concave mirror, the object will be, what happens? Virtual image. Sorry, image is virtual, upright and little magnified. Virtual, upright and magnified. So when the object is between focus and center in concave mirror, you can see the image is little virtual, magnified and upright. Okay? Only one case you can see. Here also you can see the light rays are parallel. Here also somewhere over you will be meeting here if you extend the lines. Okay? This concept is important regarding the image formations. Okay? And the same thing you can draw for convex also, please. These are the different figures for concave mirror. Same thing you can apply for convex mirror, please. Okay? Same thing you can observe for convex mirror. So these are very, very important image formation for the mirrors. Okay? So I told you just now regarding the reflected angle and other things. Concave is completed. Let us go with convex mirrors now. Okay? Convex mirror. Now for example, convex mirror, if you take image formation, I told you this is a convex mirror. Inside the surface, silver, principal axis pole, and this is the center for this convex, and this is focus, and this is the normal place. I told you normal is always passing to the center in the case of spherical mirrors, normal, NM. Now in this case, for example, if the light is incidenting at the center, I mean pole, theta. So this is the pole of the mirror. So when the light is incidenting at the pole, then what happens to the light? Again it is reflecting at the same angle. So this is for the convex mirror, please. Are you following? So angle of incidence I is equal to angle of R. Are you following the point here? So here the light is incidenting at the pole of the mirror. Concave or convex. Either you can take concave or convex, both. Angle I will be equal to angle R. So here loss of reflection can be applied. Here loss of angle of incidence is equal to angle of reflected angle. You can even go for concave mirror also, see. Even if you take concave mirror, principal axis, pole, okay, and this is center, focus. If the light is incidenting in this fashion, exactly at the pole, center. So just now I told you also. So whatever light is incident, same light rate is reflecting. So angle of incidence is equal to angle of reflection. theta is equal to theta. Even it may be convex or concave. These are some rules and regulations regarding the concave and convex mirrors. Okay, clear? Please note down. Following all of you? So unless and until you know these rules, you are not supposed to go forward. And one more thing, if any light ray is going through the center, just now I told you, it goes undeviated. Okay? It again comes back. Either it may be concave or convex, you can see. Okay? The light rays again comes back. I will show you the diagram. For example, this is concave. Okay? Light rays, pole, this is center, focus. Now suppose the light ray is going through center. So what happens? When any light ray is going through the center means again there is no reflection is there. It again comes back. Goes straight and comes back. Okay? Even it happens for the concave mirror as well as convex also, please. Convex also same thing. I'll draw that also here. Convex. See here, convex mirror also same like that. Pole. You can see this is center, focus. Okay. Here you can see light is going through the. Okay. It is incidenting here. Of course. Dotted line. Okay. So when it is going through center, you can see it is going undeviated. Coming back. Okay. Actually thing is here it is silvered actually. Okay. Suppose if any light is incidenting here, it will be incidenting with the normal now. Okay. See here. This is a normal. It will go like this in this deviation. But it is going through the center. That means along the normal. Suppose this is a normal. This itself is a normal. So along the normal, if light is incident means what? Zero angle of incidence. Angle of incidence is 0. So angle of reflection is also 0. No angle of incidence. So 0 angle of incidence. Are you following here? So when it is incidenting through the center, there is no deviation. When it is going through the center, the angle of incidence is 0. So reflected angle is also 0. So finally what happens? The reflected ray goes back along the same path. Okay? Even if it is in concave mirror or convex mirror, please. Please note down these points. These points are very, very important. Now next one, after this one, some more things we'll be discussing regarding convex and concave mirrors. Okay. Already concave I have discussed more. Convex also two more things I'll tell you for understanding in a better fashion. Right. Yes. Two more points we'll discuss regarding convex. Concave. Maximum diagrams we've done regarding the image formation in different cases, infinity, focus, pole, focus and center, focus and pole. Okay. Now let us see some more figures regarding the convex mirror, please. See here, convex, I told you, this is the structure inside, pole of the mirror, principal axis, and convex, you know, this is center, this is focus. Now suppose in this case, if the image is at infinity, for example, image somewhere over infinity, okay, image you can take some extended object, but it takes somewhere a long distance, infinity. So rays from infinity are coming. Rays from infinity are coming. You can take number of rays. Okay. Rays from infinity are coming here. You can take any number of light rays. Okay. Infinity always the light rays are parallel. Now you know when they are coming after meeting. This is the normal. Okay. Normal means going to the center. So when it meets the normal at some angle, what happens? It goes reflected. Okay, so it goes, it diverges because it is diverging. Okay, we will completely this is silver, it diverges. So these light cannot meet each other. Again, if you extend somewhere, it will meet here at the focus. Are you following? So this light after diverging, it goes like this, but it will meet at the focus. In the same way here also, if you draw normal, it diverges. So these light rays won't meet. If you extend, it will meet here. The same way here also, if you draw the normal, this angle, it diverges. So these light rays will again meet somewhere also. This is the focus. So image for the convex mirror is a virtual image, of course. It is a behind the mirror, you can see, in all cases. Okay? So light rays will be meeting at the focus place. Clear all of you? An object is at infinity. Clear? So these things are very, very important to understand in a better manner. See, in the same case, one more thing also you can study here in the case of convex mirror. Okay? Nature, position and relative size of the image here you can see. Okay. Right. So here I am considering a small figure here. Please try to understand. Last case, maybe last case of the convex. Maybe last case. Pole of the mirror, principal axis. So here already I told you for convex the center will be this side. Center. And this is of course focus. In lower classes maximum R is equal to 2F. Focus is at center only, but in higher classes small variation may be there, because in all the times R is always not equal to 2F maybe, but in lower case is taken as 2F only. Now here I am taking an object at some distance, okay, extended object AB, height of the object H0. Now here I told you in the beginning minimum 2 light rays are required to form any image. So first one I am taking like this, and of course you know this is the normal, always going to the center, normal. One light ray, this is the angle of incidence, it goes reflected, it goes diverge, you know, okay. So after meeting it diverges. And one more also I will take, and that light ray what I will do, I will go through center please. That means light ray is going through center, undeviated. Okay? So what happens? It goes again, comes back. So these two are again diverging. So if you extend those, they will meet somewhere over here. You can see that. Okay? Very small object is formed. When you extend this one, both will meet over here, somewhere over here. Okay? Between focus and pole. And the object you can see upright, virtual and diminished. Diminished. This is the nature of the image. You can see when you take the object here, somewhere over here, object, some distance from the pole, take 2 light rays, one is meeting the surface, diverging, meeting somewhere over here, another light rays I am taking through the center, undeviated, it comes back, and these 2 light never meet each other, but we extend back, they will meet over here. So the image is upright, virtual, diminished. Okay? So in all cases maximum the virtual image is formed for the convex mirror. That is the nature mainly. So image is very much virtual. You can see here going and coming back. Just now I told you when any light ray is incidenting through the normal, so incident angle is 0, reflect angle is also 0. Again it comes back, no deviation. So these are the cases regarding the concave. Clear? So these are the things you have to understand regarding concave and convex mirrors. Now we will go to the next cases, that is mirror formula and magnification, please. Mirror formula and magnification. Okay? So this is the first video I am making regarding light chapter. mirror formula and magnification. See how to remember this form, because you have lenses also, convex and concave. So the easy method I am telling to remember, mirror formula, that is relation between focal length, image distance and object distance. In the mirrors, what you will do is, generally any concave or convex, any concave or convex, this is the pole, this is center, focus, and I told you always the distance are measured from the pole. So in this case, focal length is negative, I told you before only. Radius is also negative, center of curvature, measured from the pole. So in the case of mirror formula, 1 by f is equal to 1 by v plus 1 by u, and magnification minus v by u. Okay, these are the things, formulas you have to utilize in the numerical problems, please. So in mirrors formula, relation between focal length and image of object distance is 1 by f is equal to 1 by v plus 1 by u. Magnification is in the case negative here. Okay, minus v by u. V is image distance, u is object distance. Same thing again you will be studying in lenses, please. Same thing you will be studying in lenses. There will be opposite side here. Here minus will be there, plus will be there. Easily you can remember, nothing to confuse at all. Okay, so, and you know what is meant by magnification? Magnification means height of the image by height of the object, or size of the image by size of the object. Anyway you can remember. Magnification means height of the image, whether it may be real, inverted or virtual, upright, whatever may be. Okay, with the sign you have to put the magnification values. So magnification means height of the image by height of the object. Clear? So like that you have to apply the formulas. So here this is the mirror formula and this is magnification. Mirror formula is plus here, 1 by f is equal to 1 by v plus 1 by u. Magnification is negative. Where in the lenses you will get in negative values. Okay, in lenses here you get negative here and here positive, please. Clear? Any doubts? Okay. Shall we go to the last one in this one, refraction of light? After this I may stop and we'll go to the next videos in next classes, in next video. Okay. Some more is left over, lenses and all. Then after that we have a numericals. Okay, now I will go to the last one for this video, that is refraction of light. Please try to remember the formulas. These will be using in the next coming numericals and other things. Okay. Now what is refraction of light? Very very important. Here also we have laws. Refraction of light. Already we studied about reflection. See, for example, you have two mediums. This is a normal. PQ is the surface separating two medium, air. It may be denser medium, any water or glass plate. Medium 1, medium 2. Generally air will be refractive index is taken as 1. In some books they are following as n. In some books they are following as mu. Both are correct. Either n or you can use mu. Mu you can use a refractive index or you can use n. Now suppose the light is coming like this. Light ray. Incidenting with normal I. Now this is what? Rarer medium, air. This is denser medium. Now how you can decide which is more denser, which is less denser? This all will depends upon mu value, refractive index. So whose value refractive index is more, it is called as optically denser. Whose mu value is less, it is called as optically less denser. Are you following here? Suppose here the value is 1. For example, water it is 3 by 2, 1.5. 1.5 or 1.33 please, 1.3, 4 by 3, water. Water it is 4 by 3, 1 by, glass is 3 by 2, 1.5. So whichever value is more, it is called optically more denser. So that will decide more denser medium. That means when light is entered from rarer to denser, it goes towards the normal. It goes towards the normal. In the same fashion, when light goes from denser denser to rarer. Because it is more optically denser, it is lighter medium, it goes away from the normal. This is the main meaning of optically more denser and optically less denser. In more denser, what happens? It tries, because it is difficult to go light rays, so it bends towards the normal. When it is going to lighter medium from heavier medium, it goes away from the medium. Okay? So this is away and this is towards the normal. This all depends upon the mu value, refractive index. Okay? And I have given some values you have to try to remember. Air it is 1, glass 3 by 2, 1.5, water is 4 by 3, 1.33. Clear? So what is refraction of light definition? When light ray enters from one medium to other medium, either it bends towards the normal or away from the normal, depending upon the optical density. Which is more denser, it goes towards. Less denser, it goes away. This phenomenon is called as refraction of light. Okay? Right. Now laws. As I said in before, before you discussed about laws of reflection, isn't it? So here also we have two laws in refraction. First law and second law. So first law means, see here, incident angle, refracted angle and a normal all lie in the same place at the point of incidence. You can see at the point of incidence, incident angle, normal, okay, and refracted angle all lie in same plane. All lie in the same plane. And second one, sine angle I incidence by sine angle refraction is equal to constant, and which is equal to mu refractive index, or sine angle I incidence by sine angle R is equal to, you can also call it as like this constant, because suppose the light is traveling from here, denser medium, okay, to rarer medium, okay, denser to rarer. So what he is saying is second law, it is also called as Snell's law. It is also called as Snell's law. Scientist name Snell has given this law. That means sine angle incidence in one media, refractive index of that media is equal to sine angle refraction in one media, refraction of that medium. For example, in this media light is entering. So sine angle incidence in this medium, sine angle incidence in this medium, refractive index in this medium is equal to sine angle refraction in that medium, refractive index in that medium. So this is Snell's law. So what is saying is sin I by sin R is equal to constant. Sin I by sin R is equal to constant, and which is equal to mu, and that is Snell's law. These two laws are very, very important regarding laws of refraction. Okay? These two are very, very important. Okay? That is angle of incidence, refraction angle, normal, all lie in same plane at the point of incidence, and sin I by sin R is equal to constant, sin angle incidence by sin angle refraction. And you can also define like this: whatever sin angle incidence in one media, refraction angle in that media is equal to sin angle refraction in the second media, refraction in that media, both are equal. You can find that relation like that. Are you following? Next, one more point also you can add here, that is critical angle, sin C. Mu lighter by mu denser. Mu lighter by mu denser. Critical angle, sin C is equal to, mu lighter means you can take air, refractive index 1, mu denser you can take as mu. So this formula is also sometime applicable in rare cases. Sin C is equal to 1 by mu. Mu lighter medium, that is you can take air, by mu denser medium. You can take either water, glass plate or anything. Mu lighter by mu denser is equal to sin C. C is called as critical angle. You may be wondering what is critical angle. That means for that angle of incidence in the denser medium, the light will be making 90 degrees with the normal or grazing the surface. That is called as critical. This will be studying in higher classes. Now it is no need. Just take it as granted. Sin C is equal to 1 by mu, critical angle. Okay, that is mu rarer, mu lighter by mu denser. And sin A by sin R is equal to constant mu. You can apply in the numericals. This is second law of refraction. First one, angle I. And at the point of incidence, incident angle, refracted angle and normal all lie in the same plane. There in reflection, angle I is equal to angle R. And at the point of incidence, incident angle, refracted angle and normal all lie in the same plane. These things are very, very important, please. Clear? Clear? So these are the things regarding refraction laws. Now I'll end up this video in light part 1. Now in second video what we'll do is, second video, some small concept is left out, that is refraction through slabs, glass slab. Refraction of light through rectangular slab or glass slab and application of Snell's law. Application of Snell's law. Just now I told you, no? Snell's law. That means, see here, what we'll study in the next concept is, what is mu, refractive index? How to define? See, in general, refractive index is given by C by V, that is velocity of light in air or vacuum by velocity of light in second medium. This is velocity of light in air or vacuum by velocity of light in second medium, that means other than air. So this is how you can define mu is equal to C by V. This implies mu is inversely proportional to speed, or mu V is equal to constant, or mu1 V1 is equal to mu2 V2, or mu1 by mu2 is equal to V2 by V1. Very, very important. Very, very important formulas. Mu1 by mu2 is equal to V2 by V1. Speed of the second medium, speed of light in second medium by speed of light in first medium. Refractive index mu1 by mu2 is equal to inversely proportional it is. So speed of the light in second medium by first medium. This is the relation between refractive index and speed. Okay, like this also you can define. And what is the other definition of refractive index? Snell's law. Mu is equal to sin I by sin R. That is sin angle incidence in one medium by sin angle refraction other medium is equal to constant, and which is equal to mu or n according to the rules and regulations. Some authors they are using mu as n, some books they are following mu. You can use either one. So this is the exact definition of the refractive index and as the application of Snell's law. Clear all of you? Right. Now if you go in the next video, I anyhow will complete this chapter, light complete, because in the next video I will discuss some more, that is lenses are left over and also lens formula there, magnification regarding convex and convex lenses, concave lenses, images formed, okay, and numericals, around 19 or 20 numericals in the second part video. Last one I will tell and I will end up this chapter. I end up the chapter means end up the video here, and later on second video we will discuss. That is in glass slab, how the refraction is taking place. Okay. For example, if you take any glass slab like this, this is air, medium 1, this is glass, medium 2, again medium 1 air. So three mediums, air, glass and this thing. Now suppose if you take a normal NM here, light is incidenting with the normal I. Because rarer to denser, I told you just now, it goes towards the normal R. Now again it is meeting the second surface, another normal, N dash. Now this angle is angle of incident, but according to mathematics this is equal to this one, alternate angles. Now from denser it is going to rarer. This is heavy medium, this is lesser. So what happens? It goes away from the medium, refraction angle. So this is the basic structure in the glass slab, refraction. So here you can apply Snell's law. When coming from air to denser, glass, glass to air. You can apply and you can check also. For example, this is I1, this is R1. And make a note, this angle is equal to this angle, you can see mathematically. So apply Snell's law at here, point A and point B. Snell's law. Applying Snell's law here. So just now I told you what is Snell's law. Sine angle incident into that medium, sine angle into refractive index of that medium is equal to sine angle refraction in the second medium into refractive index of the second medium, that is glass slab. Okay, so you can write down like this: sine I1 by sine R1 is equal to mu G by mu air. This is one relation. Now apply here at B, again Snell's law. So sine angle incidence. Just now I tell you this angle is equal to this angle. What is this one? R1, isn't it? R1. So sine R1 into refractive index of this medium, that is glass, is equal to sine refraction. Let it be somewhere over R into refracting index of this medium, that is air. Equation 2. Clear? So like this you can apply Snell's law for the glass slabs also, and easily you can solve the problems. If values are given, you can put it and finally calculate the values of the special refractive index values. Okay? So please prepare well the concept. Unless and until you know the concept, you cannot do the numericals, please. In second video, I will be discussing about lenses, convex concave lens and lens formulas, okay, and ray diagrams, and finally magnification and some numerical problem. So that will be the second video. Later on I will discuss in the second video. Please prepare well. Okay, lot of scoring in this right chapter. Okay, right.